Whenever you carry out a t-test, you must first state your null hypothesis. The null hypothesis states that there is no significant difference between your two datasets. In this example, the null hypothesis would be that there is no significant difference between the length of the leaves in the sun versus those in the shade. You should note that you will need a minimum of 10 repeats or points in your dataset in order to carry out a t-test. In this example, both dataset 1 and dataset 2 have 11 repeats. When carrying out the t-test in Microsoft Excel, Excel provides you with a p-value, and I'm going to show you how to interpret that in a moment. Choose a cell where you want the value to appear, go to the top blue enigma sign and select More Functions. Here you should search for t-test and double-click. At this point, we need to define a few parameters to Excel. The first is Array 1. Array 1 would be dataset 1, so click in there and highlight your dataset 1. Array 2 would be similar. Click in that box and highlight your dataset 2. Now under Tails, you want to select a two-tailed t-test. In this case, you do that by typing a number 2 into the box, as indicated in the instructions. Then click in the Type box and you want to choose toSample equal variance, and you do this by typing a 2 into that box as well, as indicated in the instructions. Once you've done that, you can press Enter and your p-value will appear in the cell that you originally selected. Now for interpreting the p-value. In biology, we work at the 5% or 0.05 significance level. Therefore, this p-value is high, it's greater than 0.05. This means that the probability of the observed results being due simply to chance is high, and that would be the case if the calculated t-value were less than the t-critical value had you calculated the value of t yourself instead of using Excel. Now if your p-value is low, in other words smaller than 0.05, then the probability that your data is due simply to chance would also be low. In other words, it would be opposite to the way it is in this example. Returning to this example, since our p-value is high, greater than 0.05, we would conclude by accepting the null hypothesis, and that is to say that there is no significant difference between the length of leaves in the sun versus those in the shade at the 5% or 0.05 significance level. Another way to look at it might be to say that there is a 95% chance that the differences between these two groups in this example are due to random chance alone and not to some other variable. Of course, if the p-value in your own work that you calculate is low, in other words less than 0.05, you can reject the null hypothesis and state that there is a significant difference between your datasets.